Hi, I'm John Lloyd Yap, and we will be talking about buffers. The proteins in our blood have a problem. They have to have a specific pH, and if it changes radically out of this range between 7.35 to 745, they start to denature and they can't do the job that they're intended to do, which is to carry oxygen and carbon dioxide. Thankfully, we can use a buffering system. So, what is buffer? A buffer is a solution that can resist pH change upon the addition of an acidic or basic components. It is able to neutralize small amounts of added acid or base, thus maintaining the pH of the solution relatively stable. But the buffers is like a scale which balances off the acidic and basic components in our body. Buffer solutions have a working pH range and capacity which dictate how much acid or base can be neutralized before pH changes, and the amount of which will change. So it has working pH range and capacity, meaning it is limited. So if a body has too much acidic components, it will tip off the balance and can cause major problems, and no more buffering action towards the weak acid is possible. So, what is a weak acid and what is its relation to buffers? So, what happens is the carbonic acid that is created when we add carbon dioxide to the water is a weak acid, and it has a conjugate base. And so that creates what's called a buffer solution. What does that mean is that if we add more protons to it, it will simply push towards the left, and if we add more hydroxide to it, it will simply push more towards the right. And so it keeps our pH fairly stable, and that's how buffer solution works. So pH, remember, is based on proton availability. It's the concentration of that proton in solution, and so we want to keep that as stable as we can. And so we use a buffer solution to do it, which is essentially a weak acid and its conjugate base. And so what's going to affect the pH of that reversible reaction? Well, the first thing is the pKa, which is going to be the equilibrium constant. And so if we want to keep that equal to our pH or around our pH, that's going to keep our pH stable. Also, we could look at the concentration of the acid to its conjugate base. If we can keep those values equal, that's going to increase the buffer capacity. Well, yeah, what are we doing here? Well, we've got a weak acid and a reversible reaction that forms this hydrogen ion and its conjugate base. And so in a good buffer solution, we want the weak acid and the conjugate base to be equal in values. And so what happens? Let's say we add hydronium to that. Let's say we add a strong acid to that. It tells us that if we add more onto this side, it's simply going to push it in the other direction. It's going to push it more towards that weak acid side, but since those values are equal, it's not going to change it very much. And our pH value is not going to change it very much as well. If you look at adding a base now, if we add hydroxide to it, what is it going to do? It's simply going to push it more towards the right, and so what happens is we can add strong acids, and it's going to keep that pH a relatively stable set point. Okay. So, what is the importance or use of buffers in our body? Well, buffers in blood is crucial to our survival. pH of blood must be kept constant for normal body functions to work. If blood becomes too acidic or too basic, then the enzymes and proteins are unable to function. Again, buffers usually consist of a weak acid and its conjugate base. This enables them to readily absorb excess hydrogen ions or hydroxide, keeping the system's pH within a narrow range. So, let's say this person you see here is running non-stop. He will produce a large amount of hydrogen ions by aerobic respiration. His lungs may not be able to remove carbon dioxide quickly enough to drive the buffering reaction forward and keep the pH range stable. So if it gets too low, the guy will have to slow down or stop, limiting their performance. The kidneys are also slow to respond, and bicarbonate ions may be used too quickly for the body to stabilize them and removes hydrogen ions by urinating.